this is for Year 10 Methods Pathways. We're going to look at exercise 10.4, question 12. So a fifth die is rolled again and again until the result is 6. Copy the table below and show the probability will take place in the indicated number of rolls. So, and round the decimal place to 3 decimal places. So this is telling us it's a calculated question. So the concept is more important than the actual calculation, even though you do need to get the calculation right. So we know that the probability of getting a 6 in one roll is very simple. It's only a 6. The probability of getting a 6 in 2 rolls. Okay, let's interpret what that means. It means that in the first roll, I don't get a 6, which means the probability of that is 5 over 6. But on the second roll, we do get a 6. The probability of getting 6 in 3 rolls means that I'm not getting a 6 on the first roll, I'm not getting a 6 on the second roll, but I'm getting a 6 on the third roll. Okay, so that's my probability of getting a 6 in 3 rolls. The probability of getting a 6 in 4 rolls is similar. I'm not getting a 6 in the first roll, nor the second roll, nor the third roll, but I'm getting a 6 in the fourth roll, and so on and so forth. Now, since it's a calculator question, I did this on the calculator, because I know a 6, remember to go into decimal mode, okay? If you tap this, you can either have it on standard or decimal. Standard gives you exact fraction answer, okay? That might be useful for most of the questions. But in some instances, when we're asked to find decimal answers, you keep in decimal mode. So 1 over 6, I press execute, I get 0.167, 167, to various places. On 2 rolls, 0.139, 3 rolls, 0.116, 4 rolls, 0.096, 5 rolls, 0.080, and 6 rolls, 0.067. Now, part B asks us, if you add the probabilities from part A, what sum do you get? You get around 0.665 if you add them together on the calculator. Explain what this answer means. Okay, what this basically means is that even though we're expected to get 1 6 in 6 rolls, because the probability of getting a 6 is 1 out of 6, that's like the expected amount. We can have the situation where we can have 100 rolls till we get a 6. Okay, if I calculate the probability of getting 100 rolls before I get a 6, the probability will be very, very small. But technically, I can roll 1,000,000 rolls and still not get a 6. The probability will be very, very small, but it's still possible. It means that the probability of getting a 6 in an infinite amount of rolls could still be a very, 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 very tiny probability, but it could still happen. You could be very unlucky, in other words. So the key to answering this question is to say that even though we're expected to get 1 6 in 6 rolls, that may not occur till many, many other rolls, because that's purely due to the nature of probability. It's due to chance, because every time you have only a 6 chance to get a 6, and 5-6 chance of not getting a 6, and each time you have the chance of not getting a 6, and that could happen for a long time.